welcome. Let's see if give it a few seconds to make sure things are working. Let's see. Hello, hello, hello. There are some things that I want to do. There's something I want to do. Oh yeah. Okay. So it looks like we're working here. Howdy. So today we're going to continue. I'm just going to do a little bit of programming. I'm kind of getting back into it, I guess, a bit here. Let's see, how's the sound sound like? Kind of getting back into it, I guess, a bit here. Yeah, it sounds okay. All right, not bad. Great. So the first question we're going to start with is going to be rotating the box. There were other questions I'd worked on previously that I had other questions I worked on previously that I had solutions for, but there were more interesting things I could do with those questions, but in the interest of time, I'm not going to go through all of that, but those things are good. So yeah, we'll keep going here. Try to do about an hour of questions. Rotating the box. You're given an m by n matrix of characters, box grid representing a side view of a box. Each cell of the box is one of the following: a stone, stationary obstacle, empty. The box is rotated 90 degrees clockwise, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle, another stone at the bottom of the box. Gravity does not affect the obstacle's positions. The inertia from the box's rotation does not affect the stone's horizontal positions. It's guaranteed that each stone in the box grid rests on an obstacle of another stone at the bottom of the box. N by M matrix representing the box after the rotation described above. Okay, so basically, the way this is going to work is we're going to shift all of the stones, the pound symbols, to the right, into basically shift them all over to the right until either they hit the bottom of the box or they hit a stationary obstacle furthest to the right. So the easiest way to do this is to just count left to right each row and just rewrite into the vector where the stones are going to be. Then, because this is going to be it's going to be rotated 90 degrees, the next thing to do would be to perform basically create we're going to swap the rows of the columns, more or less. What this ends up looking like is, I think you could do a double reverse, by the way, and this works. I forgot about exactly how to do that, but basically, yeah, doing an inversion of a matrix, not an inversion, but like swapping across the diagonal. One way of doing this is you reverse the rows and then you reverse the columns. Tricky thing with that though is if you do it that way, it doesn't preserve it doesn't have the correct dimensions. So it really only works works that well for square matrices, the double reverse, or the reverse, double reverse. I could do it this way. I could add rows, add the appropriate rows. I could add the appropriate rows to make it square, perform the double reversal, and then just shrink all of it. I think that's the best way to do it. Yeah, that's probably how we'll do it. Okay, so reversing columns is not the most obvious thing, though. Trying to think. Yeah, I mean, okay. So let's start with shift. Shift stones. So this is going to be row by row. These are character vectors. Okay. Okay. Let's also let's get the rows, columns, and rows. I'm just gonna call this like G, a grid, and columns. I haven't programmed in like a month. Not ideal. All right. So the way this is gonna work, we're gonna go left to right in the row. So to do that, we could do an index is probably the easiest thing to do. And we're gonna say const char ch is gonna be row of I. We're gonna say we're gonna have a counter. St count. Or just stones. And we're gonna increment the stones. That's probably too big. Let's see, chat is, or the stream is buffering a little bit. Hold on. Let me see here. No, it's okay now. Let me refresh. Hold on just a moment. Make sure the stream is okay. Uh-oh. Is it working? Hello? Hello. Okay, looks okay. Stream status is poor. Okay, so it's gonna buffer a little bit. Hello. Seems okay. All right. It's been a few minutes now. Okay. So this is gonna be stone ch equals this character, and then we'll say if ch is an asterisk, or yeah, it's also if stone's greater than 0. So what we're going to do is when we get this asterisk, we're going to write all the stones backwards. So we're going to say for int j equals I minus 1, stone j is greater than 0 equal to 0, and stones greater than 0. We're going to decrement j, and we're going to decrement stones. And we're going to write into the row of j is going to be equal to this asterisk. And we're also going to write if ch is equal to we're going to say stone. We're actually going to write it. We're going to remove the stone. Basically, we're going to pick up the stones. Yeah, let's do it this way. I think this is reasonable. Okay. Yeah, and then at the end, if stones is greater than 0, We're going to do a similar thing where we write from back to front. So let's start from row.size -1. Okay. Let me just check here. Yeah, so we started the previous position. We say if there are stones, we write one in, then we decrement the stones, and then we have no stones, or we go all the way to the end. Yeah, okay, that should be fine. So that's fine. So shift the stones over. Start with that. Then we're going to add rows. Make the grid squared. Then reverse rows and then columns. Shrink the rows to make them of length and rows. Leaving the rectangular, not translation, not transformation, but it's a rotation. Okay, something like this. Is this correct? So if you had like A, B, C, D, you reverse them, B, A, and D, C, and then swap them. B goes to the bottom left. A would end up in the bottom right. Is that a 90-degree rotation? 90-degree rotation, is it? I think it's correct. I could be wrong. I may have to do something different, actually, to do this correctly. Actually, if I do a 90-degree rotation, A should end up where B is, B should end up where D is, D should end up where C is, and C should end up where A is. Does that happen? That's not what happens if I do the double reversal. That's a mistake on my part. Transform, that's what's called. Transpose, that's what's called. I'm looking for the transpose. What I described will give you the transpose. But that's not the same thing as the rotation. Also, I don't think that's correct. I don't think that gives you the transpose. I thought that gives you the transpose. Reversing both rows and columns. That's not the transpose. No. That might rotate 180 degrees. This is not the same thing as the transpose. It might be easier to just write into the new grid. The first row becomes the first column. That's all. When you rotate 90 degrees. Oh, no, excuse me. Is it clockwise or counterclockwise? It's clockwise. So the first row becomes the last column. You could just write it to a new array. It's probably easier. I think there's a way to do it without right into clockwise rotated array matrix grid. Right into a new grid. Right to a new grid. Yeah, it's easier to just write it to a new grid. I was gonna say you could do something fancy here with rotations, which I think you can, but it's maybe not worth. It's maybe not worth. So we want n columns is the number of rows, and then each row is going to be we'll start with empty, and then we're just going to say for each row in grid, we're going to actually it's probably better to do like this. Index, row index. That's probably better. Yeah. So there's going to be a row index, and we're going to write to result for each row, for each value in the row, column index. Maybe I should have just used I and J. That may have been better. Yeah, probably just I and J. Oops. That's probably fine. Okay. Is the stream healthy? Okay. Okay. Hello, 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 hello. Is the stream healthy? Seems okay. Okay. It seems all right. It's just is the stream okay. Forgive me. This is a pretty convoluted way of doing this, but I think this will work. Let me see. So where do I write into the result? I want to write in the first row is going to be the last column. So it's going to swap j and I, number one, and it's going to be n minus j plus 1 of I, n minus j plus 1, which is, this is going to be, n also is interesting. This is, it's sort of result of, oh, okay. It's m rows and n columns, but we're kind of swapping these things, right? So it's, we could make it easier and do target rows, target columns, maybe. Target rows and target columns, right? That might be better, actually. Kind of like that. But like semantically kind of makes things a little more clear what's going on here. So yeah, so this gives us the number of target rows and the number of target columns. And then so now when I'm trying to write into the last column, right, we're going to swap those I and j values. And the last column is going to be each, yeah, you're going to go row by row. This tells us which row. This is going to be the column. Okay, so this is going to be minus I plus 1. And it's going to be, it's actually, this is going to start from the back. So this is going to go row by row, no problem, straight down. But this is going to be the last column, which I think is the number of columns. Yeah, which is the size of the row. Number of columns, minus I plus 1. It's really, I think it's actually minus I minus 1. I think I've made that mistake before. So when I is 0, yeah, we're at n sort of quote unquote n minus 1 when I is 0. And then when I is, goes from 0 to n minus 1, then we're back at 0. Yeah, so that's a little confusing, but that translation should be the right one, something like that. Box grid, okay. Forgot to rename that. Refactoring while you're programming is not always the best thing. Yet something I do. Yet it's something that I do. Okay, so that seems about right. I'm tempted to just submit this. This is probably correct. Let me try. I'll probably just go for it. I don't want to waste too much time messing around with the test cases. Huh. This is new. Accepted. Okay, great. It's 0, 0, 0. Oh, okay. It's taking some time to load. Yeah, it's pretty straightforward. That took me a while though. It took me like a lot of time. How did we do? Good to see you back. What's up, Yash? How you doing? Welcome. Howdy, howdy. Howdy, howdy. Yeah, man. It's good to be back. Been kind of out of it. This was maybe not the best approach because I think it's slower. It's slower because of the I'm pretty sure I could use rotations here. I'm pretty sure I could just extend the solution. A few things, a few notes on like why this isn't the fastest. I'm pretty sure I could extend the solution by, I could just modify the grid in place. I'm pretty sure I can modify the grid in place and obviate this part, and you would just use clever rotations on the or rather clever like reversals on the grid, so you don't have to create a new one. I think that would be the fastest. I just don't remember how to do that at the moment. And then the other one is this code is maybe not the best. You probably could obviate some of this code. You could probably do better here, potentially. But this is a relatively simple idea. So yeah, there are probably improvements that can be done here. But this is okay. This also is slow to program. It took me a while to kind of like think this through, work it through, which it probably shouldn't be so. This is like not that hard of a question to think through overall. So yeah, interesting question. Some room for improvement for sure, but pretty good, pretty good. In the interest of time, we'll move on to the next one. I took quite a bit of time on that. Yeah, interesting. They've updated LeetCode, so it kind of works a little bit differently now. Hey, you're back in your car, W. What's up, Kanav? Hope you're doing well. Welcome. Howdy. Yeah, I gotta like fix up my vehicle. It's been letting it sit too long. It's gotta be you run into maintenance issues. I didn't know about the maintenance issues. So I learned about that recently and found this one already solved. And found that I would need to I actually need to like repair parts of the vehicle now. They're pretty minor things, but well, yeah, not too hard to repair, but I'm a little bit like, oh no, I didn't realize I didn't know. But yeah, if you let a vehicle sit too long, it runs into issues if you don't like maintain it properly. All right. Counter function initially returns n, returns 1 more than the previous value every subsequent time. I think actually I need to jump pretty far ahead here. I was gonna say we could resolve these questions and go over the solutions. This one, a simple thing is to just have a basically like a static variable within the function. It's tied to the function. So this returns a this is a higher order function, meaning it returns another function, but you can capture in the scope of the function that gets returned, capture basically a variable that will kind of be bound to that, in some sense bound to that. It's not really bound, but I don't know what the right word is. It's in the scope of this function, and then that allows the function to basically like utilize that counter. Let me do this. Let me do the problem list. I think I need to like scroll down a bunch of problems here. But that was, oh, okay, no, we're okay. Don't have to go too far. All right, we'll do the find the degree of each vertex. Let's go with that. You're given a 2D integer array matrix with size n by n, representing the adjacency matrix of an undirected graph with n vertices labeled from 0 to n-1. Matrix ij equals 1 indicates that there is an edge between vertices I and j. Matrix ij equals 0 indicates that there is no edge between vertices I and j. The degree of a vertex is the number of edges connected to it. Return an integer array, answer of size n, where answer of I represents the degree of vertex I. Integer array, answer of size n, represents the degree of vertex I. Okay, vertex 0 is connected to... Huh. Okay. 92% acceptance. That's a very high acceptance rate. So it's a adjacency matrix of an undirected graph with n vertices labeled from 0 to -1. Edge between... Okay. So... Huh. I think you could just add all the spots that I see in I. If I see a 1, I can add a value there. J, add a value there. And I think just divide by 2. And that's it. I think that's it. I think it's that simple. All right, let's try that. Let's give it a shot. See if that works. I think that's fine. We don't know how many there's gonna be though. Oh, it's n by n, so we already know 0 to n-1. Okay. So we can just do matrix that size. Oh no, no, we can't. No, we don't know what n is, do we? No, it doesn't tell us what n is. Okay. Right. Okay. I know what to do. Let's... Okay, we'll do it this way. Auto or const auto. Yep, via matrix. I'm gonna say if I'll do const or constant I. We can actually destructure this. Let's do that. I should do more destructuring. I think it's destructuring. Structured bindings, rather. Let's do more structured bindings. That's probably better. All right, so if I is greater than result.size, or j is greater than result.size, So then we're gonna say result dot resize to stood max ij, something like this. And then we're gonna say result of I plus plus. Oops. I don't know if this is the best way to do this. Might not be the best way to do this. It's one way of doing things, I guess. And then we're gonna say for auto val in result, val get shift to the right, 1, and then return something like this. I don't know. I mean, I kind of know. I think so. Let's say probably compiler. Okay. Cannot decompose members of an accessible base class. Oh wait, I don't think I can decompose vectors like this. No. Oh, that's a bummer. Okay. Can't use structured bindings with vectors, I think, which is kind of weird, but that's, yeah, all right. I think that's the case. I forgot about that. I think it's something like that. There might be a way to do it that I just don't remember. A better way to do this. Okay. Whoops. Oh, excuse me. This one. That's subtle. Still runtime error. Ooh. It's actually not v0, v1, so it's supposed to be v1, 2. Oh, no. Yeah, v0, v1. And then it's also, I mean, this is confusing. There's no edge. The matrix is an n by n matrix. Oh, I did this wrong. But it's, oh, I goofed. Okay, no. Don't need to, no. Wrong. It's an adjacency matrix. I'm sorry, it's been a while. It's been a while. Oh, that's goofy, man. I don't need to do any of that. Oh, that's funny. No. Wrong. It's a wrong. All right. For each row, do we add the rows and the columns and then divide by 2? Or do we just add the rows? I think we just add the rows, man. I think that's all I need to do. I think it's actually even easier than I realized. I do need this though. Okay. Oh man. Oh boy. Okay. There's actually even I could actually use to make things even more interesting here. I could use pointers to both of these. Just do a pointer to the beginning here and a pointer. Like if I could do, I'll show that next what that looks like. But this actually is a lot easier than I realized, I think. Oh man. Okay, let's try this. Yeah, I think it's that simple. Let's go with this one, see if it's right. Yeah, okay, but there's actually a slightly better thing you could do here, which is kind of unusual. We're gonna do pointer 1, pointer 2. You ready? Pointer 1 is result.begin. Oh no, we'll do pointer 2. Result.begin. And then pointer 2, pointer 1, matrix.begin. And then we say pointer 1 is not equal to matrix.end. And what we're going to do is actually do pointer 1 and pointer 2. Also, I'm starting to lag here. How come you're streaming on Tuesday? I remember you saying in one of the previous streams that you get time only on weekends. Just followed by some intro with a JC matrix degree. Yeah, you're right. You're right. Oh, n squared's optimal. It's the first whole matrix anyway. Yeah, you're right. You're right. Um, I give me 1 second here. I think it's pointer 1 begin and pointer 2 or pointer 1 end. And then we can obviate this. Oops. I'll explain what happened with the weekend in a moment. And we can do pointer 2. There we go. This is a little bit better, I think. I'm not sure if this is any clearer, but there we go. Yeah, this is a little better, I think. But yeah, you're right. This is actually much easier than I realized. Okay, it's still a little bit on the slower side, though. I'm a little bit unsure about why. I mean, maybe I could just write into the matrix itself to speed this up a bit. Although I think actually when the runtime is so low like this, it's just kind of random whether or not it's the 0 milliseconds or yeah, it's sort of a random thing. But I might be able to actually go even faster here and do this. And write into I could do something like this. It might be a little bit faster. Yeah, let's try that. There was something I wanted to say. Oh yeah, about the weekend. Yeah, so my schedule is there we go, that's a lot faster. So yeah, my schedule is varied quite a bit. The schedule's not really set, which is kind of annoying. So I actually have like random time. There we go. That's what I wanted. Okay, let's go to the next one. Also is the stream still stream health there. Stream is healthy. Okay, great. Great. How are we doing on time? We're doing okay on time. Yeah, that one was a little bit faster, I think. Although I spent a little bit of extra time on it. All right. Solve this one already. Let's see if we this is solve. Yeah, that was kind of my mistake. I didn't realize how easy that question was. It took a while. It took a while. That's okay though. It wasn't too bad. Integer array nums of length n. Construct a new array ants of length 2 times n, such that the first n elements are the same as nums, and the next n elements are elements of nums in reverse order. Okay, I from 0 to -1, answer y equals nums y, answer y equals n equals nums. Integer array answers. Wait, what? New array, twice the length, the first elements are the same, the next n elements are the elements of nums in reverse order. Oh, that's interesting. Okay, this isn't too bad. I think we can just use some basic functions here. We can actually do, I don't know if we can resize. I might be able to. Take a try. I'm actually not sure. And then we can do std copy from nums.begin. Nums. It's not end. It's going to be nums.begin plus. Maybe I do want the size first. Plus n is going to be copied to nums.begin plus n plus 1. Something like this. And then return nums. I think this works. Let's see. No. Okay. Oh. Did I not add this? In my mind, I corrected that, but oh no, wait, oh shoot, did that? I made the wrong correction. I added a 1 instead of, okay, well, anyway, buffer overflow. It might be n-1. Something like this, I'm not sure. I have to double check. I need to reverse this too. Yeah, I forgot to reverse it. You could technically do it in reverse. I don't know, I could try that. What does that do? I wonder. I wonder if that works. That'd be pretty funny, huh? No. What does it do? Oh, okay. 1, 2, 0. Huh. What about this? Oh, it works. There you go. That's cool. Fun with iterators, huh? Fun with iterators. There we go. Pretty good. Not bad. That's a good one. That's a good one. All right, debounce. I think we already solved this one. This one I don't remember. I remember this being like kind of a pain in the neck. Yeah, that's funny. Okay. All right, I might need to. Yeah, let's go back to the list. Okay, concatenate array with reverse. We just solved that one, right? Digit frequency store. Okay, how are we doing on time? 40 minutes or so. Seems alright. It's just the stream is healthy. Okay, it has an error. Okay, so it's buffering a bit here. Give it a moment or two. Give it a few moments. Okay, looks like it's coming back a bit. All right, that's good. That's good. So the next question is going to be digit frequency store. Just make sure this isn't right. Okay, we're fine. All right, let's see. Given integer n, the score of n is defined as the sum of d times frequency of d over all distinct digits, where frequency of d denotes the number of times the digit d appears in n. Return integer denoting the score of n. 5. Digit 1 appears 1 time. Digit 2 appears 2 times. Okay, yeah, this isn't too hard. This isn't too bad. So we're gonna get so we'll start int digits or frequency array 10. Initialize to 0. I think works this way. And then we're gonna do while n is greater than 0. Oh, just check for n. N is at least 1. Okay, so n is greater than 0. We're going to say constant d is n mod 10. We're gonna bit shift, or we're gonna divide equals by 10. And frequency of d, increment by 1. And then we're going to say return instead accumulate. I could use this transform, I think. Transform. There's a function, I forget what it's called. It's like C++. Transform. Reduce, I think is what it is. Yeah, it's transform reduce. Let's try that. So the transformation, it's going to be frequency plus 10. Start off with 0, I think. Yeah, input first, last, first in it. And then first, last, first in it, reduce, transform. Yeah. So in it, first, last, first in it, reduce, transform. Okay, so first, last, first. Init reduce transform. So this part is going to be basically, oh, but I also don't have the access to the index, so it's so annoying. One way of doing that is to just have a variable index, and the transform, we're going to increment index, and we're going to return index. You could just start off at -1. This is one way of doing it. Val, that's going to be index times val. That's the transform, and then the reduce is just a sum. Stood, I think, just add or something. Add, I don't remember exactly. And there you go. Yeah, it's probably easier just to write the for loop. It's probably easier to just write the for loop there. Also, I'm not sure if that's correct. It's not add. Stood transform. Oh, this is going to take too long to reload, huh? CPP add or transform reduce. I don't remember what it is. It's like multiplies or addition or whatever, something or other. Iterate. I'm looking for. No. Isn't like. Hold on. Let's do it this way. Okay, CPP transform reduce. Add. Similar to stood multiplies. I don't remember what these are called. Reduction operation multiplies inner product. No, plus. That's what I'm looking for. Plus. That's not plus. Yeah. Gotta remember this syntax. Definitely would have been faster if I used. Definitely would have been faster if I used just a raw loop. A raw loop would have been faster. All right, I gotta go. I'll wait for your next stream. See ya. Okay, take care, Kanav. Hope you have a good day. Take care. Talk to you soon. I appreciate you coming by and saying hello. Do appreciate it. 2 arguments. Can function on failure. What did I do? Okay. What happened here? Sometimes AI could just tell me what's wrong. So this should be a little bit more visible. UB, okay. Order, oh, it's UB. Oh, that's not good. Pure, okay. Accumulate, guaranteed order. Okay, I should use accumulate, okay. And avoid mutable state entirely. Cannot easily do it with stood reduce. Okay, so I suggest just use the basic approach, man. Oh, that's funny. Okay. Okay. Aside from that, Oops. Had that open, tab open. I thought this was the correct setup here. First, last, init, reduction, transform, 6 arguments, 2 range, overload, 7 arguments. Oh. 2 ranges. 1, 2, 3, 4, 5, 6. Order and types. Ah, it's a binary function. Ah, that's why. Okay. Oh yeah, I should have noticed that. It's a binary operation. Got it. Transform is a y. Wait, what? Wait, why is the transform a binary? One from the first range, one from the second. Oh, elements from both ranges. Okay. In one range. Wrong overload. Simple loop. It's not generated. Oh. Interesting. Uh-huh. Oh. So I think I can kind of coerce this into what I want, but it's definitely confusing. Okay, let me submit this. So this will introduce UB, but let me just see if it's correct. All right. Definitely accepted. Okay, great. So not good, but works. Probably the raw loop is better here. Quite frankly, the raw loop is probably better here. All right, let's try this. So still accumulates a lot better because it doesn't introduce UB. Yeah, I should have noticed that that was a binary operator. I just didn't. Oh, no. So this is also a binary operator, I think. By the way. Yeah. Interesting. Interesting. I don't know, man. I don't know. I don't know if the other one was supposed to be the accumulation binary operator. For the reduce. Something like. The reduction operator. Okay. Gotcha. Should be, what's the word for this? Sequential. think there's a way to do that. So a lot easier than all that is to just use a raw loop. Just use a simple raw loop. Yeah, it's kind of over engineered. Yeah, that's just a lot simpler, a lot easier, a lot quicker. Okay. So it just adds stood execution sequential, and that would work fine. It's a logically fragile but defined order. Critical caveats, signature mismatch remains. Still be binary, logic flaw. Both ranges be identical. Need an index counter. Awkward even with sequential execution. Simple for loop to accumulate. Okay. Fair enough. Yeah, it's kind of what I was thinking. I was like, this transform reduce works here, but it's not the best. Okay. Moving on. Moving on. All right, how's the stream health here? Healthy. Okay, I got a few more minutes. Let's take a look at this one. Oh, we already saw this one. Okay, let's try another one. Maybe I'll look at the list. I normally would resolve the ones already solved, but because we have to go through so many questions, I'd rather not do that. Okay, reload more. Nice. Please reload. Okay. Can I use the no? All right. Sometimes UIs act in weird ways. Browser UIs. Like I wanted to use the arrow keys up and down here, but it for some reason doesn't work. Suddenly not working. Oh wow, that's a lot of questions to go through, man. It's a lot of questions to go through. All that work and time, huh? Oh, there we go. Beautiful. All right. Sum of squares of special elements. Okay, this might be a little bit harder. Let's see how this goes. All right. One index integer array nums of length n. One index integer array nums of length n. An element nums of I of nums is called special if I divides n, i.e. n modulo I is equal to 0. Return the sum of the squares of all special elements of nums. So a one indexed array nums of length n. Nums of I is called special if I divides n. Okay, so in this case we have 1, 2, 3, 4. 1 divides 1, so that's special. 2 divides 2, so these all divide, and then I get the sum of the squares. All right, I mean, this is pretty straightforward, I think. So just have results. Now, I do need to check something before I do this, which is, what are the bounds? There's only 50 elements, okay. But what are the size of those elements? Well, almost only at most 50. Okay, so 50, I think it's 50 cubed fits in 50 cubed fits in an integer. Okay. So this is pretty straightforward. It's going to be result plus equals, so it's going to be nums of I modulo equals 0, right? Times nums of I times nums of I. Something like this. Something like this. Runtime error, division by 0. I plus 1. 1 indexed. 1 indexed, my guy. 1 indexed. Oh, it's wrong. Oh, 30. 1 plus 4 plus 9 is 14 plus 16. Oh. What? What? Uh-oh. Uh-oh. 1 divides 4. Oh, maybe I misunderstood this. Uh-oh. 2 divides 4. Sum of the squares of all special elements. Wait, what? Oh, if I divides n. Okay. A little bit different. Okay. Got it. A little bit different. Still not much harder, but slightly misunderstood that. Okay. Should be... I think the compiler actually deals with this appropriately anyway. Okay. Is this right? Is this the... So 1 divides 4 makes nums 1 special. 2 divides 4 makes nums 2 special. 3 does not divide 4. And 4 divides 4. Okay, that's confusing. Okay, a little bit. I can see why this would be a question worth thinking about or asking. What makes something over-engineered? That's a really good question. I wouldn't say it's easy to tell that. It's actually not trivial to figure out if something's over-engineered, but basically it means like it's a kind of offhanded way of saying that something is more complicated than it needs to be. So like in the case of that other question, I was trying to... Give me a second here. Yeah, so this is a skill that, like, if you're interviewing for startups, for example, they actually kind of test for people who over-engineer. So they test as a filter to filter out people that over-engineer things. So basically, it means that you're taking too much time and resources for something that doesn't need to be that complicated. And a lot of the time, that comes from, like in my experience, comes from like over-generalizing too early or over-optimizing too early. So like sometimes, like a good example would be like if you have code and you don't want to, you want to make your code more general. You don't want to copy paste the same code in several places, right? Like you want to avoid code duplication. So sometimes you write a function that does basically the same thing with maybe a few parameters or something, and then you call that function a few spots, and then you avoid duplicating the code. So like that's a case where it's not really over-engineered, like it generalizes well. But there are cases where it's like, okay, but now maybe you want to overgeneralize, like you want to do too much of that. And I've done things like that where I was like, okay, let me try to like write a function that allows me to avoid using 2 for loops, right? So like sometimes things, so a really simple example is like if you're working on a grid type question, going row by row is it's like a few lines of code in C++. It's like standard accumulate. Usually you could evaluate something over a row. But evaluating something over a column, you need to use a raw for loop and loop through the column elements, which ends up being like 3 lines of code, or sort of, not really 3 lines of code, but it ends up being like a for loop with a line of code inside of it, and it ends up being a little bit more involved. And so if you wanted to like write a function that can, I guess, work through multiple different directions through a grid in the same function call. So you could do the row, the column, and then like a diagonal, right? Which I've actually probably showcased something similar to that already. that's like a spot where you might have over engineering, where it's like you don't need to do all that. or there's like a really simple way to do it and you just do that and you don't go through all that extra hassle. I'm not sure that's the best example of over engineering, but that's kind of something that software developers who are more familiar, more comfortable with like big tech companies, for example, like if you work for a big tech firm, and they've got like tons and tons of money and they've got lots of time, they've got all the resources in the world, they got all this stuff, they'll go for like super complicated solutions sometimes when it's just not necessary to do all that. I see, thanks. Yeah, hopefully that makes sense. It's not the easiest thing to explain and not the easiest thing to give examples for, but it's kind of a pain point for software engineers who are looking to get into startups from like a big tech firm. They just have a lot of time and resources at the big tech company, so they'll spend a lot of time working on projects that are probably not necessary, potentially, or elements of projects that are components that are probably not necessary, but are like super complicated, super sophisticated, but in the end, like it was like too much. Whereas startups is like on the other end, where startups they don't have a lot of resources, so they don't have a lot of people, don't have a lot of resources, so they're like super lean and they're trying to like get things done really quickly, and not use a lot of resources. Yeah, so that's over engineering. That's kind of something that they test for, and it's a bit of a skill. It's a bit of a skill to develop, like to figure out whether or not something is over engineered. So like as you saw, like in that case, trying to like coerce the transform reduce thing into what I needed was like way more than was necessary. Like I could just use a simple raw for loop. The reason why I was thinking about the accumulate versus transform reduce versus the for loop, all that stuff, why I was even thinking about it is that employers will test you for like your knowledge of a programming language, and like they want to see that you're, for example, in C++, they want to see that you're using the STL, you're using the algorithms library. But if you try to force it into places where it just doesn't really belong, that would probably be like just over engineering or just kind of unnecessary. Okay. Some people could argue, you could maybe make the argument that a lot of what they're doing with AI now is maybe some over engineering, where they're like trying to replace people with things that are way more complicated and way more expensive than it needs to be. It's maybe a topic for another time though. Reverse letters then, but yeah, you see the big tech companies are really leading on that, whereas a lot of other companies are either they're doing things downstream from that or they're just not doing that. They're just not working on the AI stuff. All right, reverse letters, then special string characters in a string. You're given a string S consisting of lowercase English letters and special characters. Okay, the task is to perform these in order. Reverse the lowercase letters and place them back in the positions originally occupied by letters. Okay, reverse the special characters and place them back into the positions originally occupied by special characters. Turn the resulting string after performing the reversals. Okay, so basically, what I'm going to want to do is keep track of the indices for the special characters as well as the lowercase letters and reverse these sections, these pieces. This is a little awkward. There are a few ways to do this. What I would like to do is try to do it in place on each one. What I could do is I'm thinking about just splitting this into two strings. Here's one way of doing it. I could save the indices of the lowercase letters and the special characters. Save them in an array. Each of them in two different arrays. And then I can also write those letters to a string, reverse each of those to separate strings, two strings, reverse those strings, and then write those strings back character by character into the original string. Yeah, it's one way of doing it. There's probably better ways of doing it, but this is like reasonable. This is reasonable, so we'll do that. So we'll do for const char. Oh no, we want the indices. So int I is 0, I is less than the size, increment I. I think this will be the last question for today because I made a promise to somebody that I would give them a call sometime soon. So let's do that. So we'll do std string lower special and then we're gonna have std vector lower. These could be chars, right? What big is this string? Yeah, it's a small string. This is maybe not the best way to do this, but it works. Lower indices, and then special indices. And we're gonna actually we're gonna do this like this. We're gonna do lower indices dot. It's not resize. It's CVP not resize, but okay. Forget what this is called. There's another one too. Or it's not resize, but it's like not reserve. That's the one, reserve. Yeah, that's better. This is probably fine. Oops. Oh, thank you. Oh, this is really taking a long time, huh? I'm just gonna say thank you. All right. So we're gonna return s at the end of this. We're gonna say so if ch is and 32 really is lowercase letter. Okay, it's either so it's either one or the other. Then we're gonna say lower indices dot pushback I and lower plus equals ch. And the other one's gonna be special. In this case, it's simple enough. Well, not simple enough, but there aren't any forgot what it's saying here. There aren't any uppercase letters, so we can just go straight for the else here. Okay, we're gonna say s of I. Let's do 0. I actually don't need to do it this way. This is that's not necessary. We're gonna do s of lower indices of I is equal to, oh, we're gonna reverse too. Okay. Lower of I, something like this. We just write in these two. It's something like this. We just write those values in. Just keep it kind of simple. Runtime error. Okay, not great. Great. Oh. Yeah, did that one. It's wrong, but it's not crashing, so that's good. Output expected. Okay, pretty close, but maybe I can't do the N32. Maybe just do. It's not as easy as I thought. Sometimes, yeah, it might be it. Okay, let's do CH is greater than A, CH is less than 2. C. That's probably a little easier, a little more logically, a little bit easier to grasp. There we go. Okay, let's go for it. All right, it's fine. I mean, it's not the best in terms of memory, but it's fast enough. Maybe it doesn't. It's okay. It's okay. It's not the best. This is not the best way to do it. I don't really like this approach, but it works. I'm sure there's a better way to do this. Not the. Yeah, it's all right. It's okay. I'm just gonna say it's okay. Okay. How's the stream doing? So I think that'll be it for today. How's the stream health? Stream health's not the best. Oh no, it's okay. So let me stop here. Thank you all for watching. That was fun. Did a few problems. Kind of got a little more practice, and yeah, obviously some things are just even within a month. I'm already forgetting some things. Yeah, man, I like LeetCode. It's fun. I do like doing the easier problems. It definitely makes me feel better. There are a lot of ways to do them that are like, there are more clever ways to approach them, I suppose. It's a good idea to solve it, and then you can look at the other submissions somewhere here. Let me see. Yeah, it's a good idea to click on this and look at the other solutions. I didn't know you could do that. I watched somebody else using LeetCode, and they showed that you could do that, and I was like, oh, that's cool. They didn't do that. They like didn't intend to show that as like a learning thing, but I just saw them do it, and I was like, oh, I didn't realize I could do that. So yeah, it's good to kind of look at other people's solutions and see like what clever things they threw in there. But yeah, I think I'll stop here. So thank you all for watching. If you like the stream, don't forget to like and follow. Have a nice day. Carpe diem. Yes, sir. Yes, sir. Yes, you get the right idea, man. Carpe diem. Heck yeah. Heck yeah. So I'll stop here. You guys have a good rest of your day. Carpe diem is right. And yeah, like, follow, all that stuff. Share if you want to share. If you're interested in doing that. Oh no. Yeah. Share. And what else to say? Yeah, take care, everybody. Thank you all for watching, coming by. I appreciate it. Have a good day. Have a good day.